I don't know if anybody tried the last couple questions here, but we can give these a go. Same thing as yesterday, but not, well, it's kind of, but not really, which is an interesting question. Has anybody had a look at this? What I would do, okay, if I see that division, it's not too often in math, like we start moving away from like multiplication and division signs. As you get a little progressive, like in terms of like 9-10 math, by the end of this course, we're going to try and move you away from using these symbols. It's not that they're not there anymore. They still exist. You might still see them, but this division, we don't really write division this way anymore. Okay? It's not too often I'm writing any solutions, even in grade 10. Like I don't know the last time that I did this in a math like lesson. You kind of phase it out a little bit, right? So it's not too often you see that anymore. So I would like, if you see this, what's another way to write this? We kind of talked about that a little bit yesterday. I would take the one piece, the first piece, right? And I'd put it over top of the second piece, right? So it would look something like this. Same thing with the dot, right? Now we've learned that the dot implies multiplication. Okay. Now what? Oh, what did I miss? This is pertinent information to you. It's important for me because I have to teach you, but I sometimes forget because I never like, this wasn't emphasized for me. Okay. What did I miss in this line? Brackets. Yeah, I mean, you could put the brackets in. Brackets don't do too much. Yeah. The equal sign. Don't forget the equal signs, okay? We were just having a lengthy conversation in the staff room about this. Equal signs and like all the formalities that just seem to like just get lost, okay? So what's the unique thing with this particular question? There's no plus and minus signs, right? I think maybe we saw a little bit of that yesterday, okay? There's no plus or minus signs, which makes your life easier. Happy to see that. Okay, because that means you could do something like this. You could do, does anybody want to divide 93 by 116? I don't know what that is, right? What you are free to do though is you can do the 116 divided by the 116. What is that? Yeah,
1.
It's just 1, and then it's got a negative on it, right? So what we're allowed to do is just go like this, -1, right? And then that's going to be multiplied against whatever this quotient is. Do we know the word quotient? So we've got, in math, we use words like sum and difference. Those are maybe the ones you're most familiar with. But when we multiply, what's the result when we multiply? What's the word? Yeah, Ali? Product, okay, and what's the result when we do division? This might be a new one. Maybe some of you, I don't know. Yeah. Okay, Ali. It's quotient. Okay, so it'll look like this. Ooh. That look right? I think so. It looks all right. Okay. So what's the quotient here? When I do 93 divided by 31, what's that?
3.
It's 3. That's it. Okay. So you go -1 times 3. Right? -3. If you don't believe me, there's nothing wrong actually. And if this was a calculator, remember that. Just to bring you back here for a sec, all these questions have been written from the standpoint of, can we do this without a calculator? Well, let's say you didn't have a calculator, right? And you didn't believe me in the way that I just did that. You would get the same result if you typed all of this in your calculator. I don't know what -116 times 93 is. I don't know what that is, but the number, whatever the number is on the top, divided by whatever the number is on the bottom, when you divide those two things together, they'll come out to be -3. Does everybody see what I did there? Just Okay, so what I'm saying is if you actually did the math in the numerator and did the math in the denominator and then divided them, that should come out to be -3. Okay, so our job is to try to give you some tricks, right? So as we go through, this is a relatively straightforward question because you've got 116 and 116, the number was the same. But it is also a good question from the standpoint that we had this 93 and 31. Okay, because you can divide 93 by 31 evenly. Okay, and so our job is to try to get you to see some of those little patterns so that you can do this without a calculator. Okay, so what's next? What do you want to do here? Is there a way to rewrite this? I might rewrite this. Might do this. Now, before I go any further though, I'm going to do something and see if anybody agrees or disagrees. Remember about like 3 minutes ago I said you're happy not to see plus or minus signs in the question, right? This one you see a minus sign. So I guess my question, what this is doing is trying to bring your attention to this. You tell me if this is allowed or not. Don't write this down, you just tell me if it's right. You guys have a good think of that. I don't want to move on unless everybody's had a good thought at that. In theory, that seems like we haven't done anything wrong. You've got to be careful when there's a plus minus sign. Yes, Coulson?
You need to remember order of operations. In this case, there's a bracket for...
Fair enough. Yeah, let me draw the bracket here. We're going to spend some time looking at order of operations today. That's going to be the whole premise. And I guess this is like Mr. Polney's done a good job at like putting these lessons together in a nice sequence. But you'd be surprised at the number of people that don't do that, like the brackets. I suppose if I did put the brackets there, then it's kind of like, okay, it's kind of silly for you not to do what's inside the brackets first, but there are lots of instances where there aren't brackets. And then we see this happen. We go 12 divided by 6, take away 18. See that all the time. Is that allowed? It's a good question. I guarantee some of you are going to do it at some point, especially when you're like, you get used to not using a calculator and you get a little too cocky, right? And you're like going too fast, and then you end up just doing this, and then you get the wrong answer and you don't even know, right? What this is saying, you got to remember what this says. So the order of operations is totally valid. That's what we're going to spend all our time doing today. But more literally, what you have to remember is when you write like a big line underneath everything like this, that means everything's divided by 6. You can't just do one and then not the other, right? So another way to write this would be like this. If you wrote it like this and then did the math, it'd be perfectly okay. That's fine, right? This is like common denominators and just adding, subtracting fractions. We're also going to do that, okay? But now if you were to actually evaluate this, it's a little easier, right? It's not 2 take away 18. What is it? How many times does 6 go into 18? Or what's 18 divided by 6? 3. Okay. Now, yeah, that's right. Okay. Does anybody have any questions with that? That's going to be something that comes up. I remember, this is me like thinking back to myself in high school. I remember doing physics and doing exactly that. I remember the instance, not the exact question or anything like that, but I remember like the moment in time where my teacher's like, you can't do that. There's a plus sign there. All of it's divided by whatever it was. That's all the way into grade 12. Okay, so it doesn't have to be that. It could be something. And a lot of the time, like, something just goes under the radar for a very long time. Something that we were talking about. What did I say earlier? kids not being able to expand brackets or not writing equal signs well into grade 12 or something like that, right? Like multiplying fractions, that's what I said. Okay, I've seen that, not being able to do that in a grade 11 course. Something like that just flies under the radar for everybody. One or two things, one thing, right? And then all of a sudden it gets you a wrong answer somewhere down the road. So I guess it's our job to try and minimize the number of those as you move through high school. And this is a common one. Okay, just dividing one thing by the denominator instead of both of them when there's an addition or subtraction. Can everybody see how those two questions are different? That's very important, okay? These two questions here. There's a reason why these are both here. Okay, they're similar, but they are different. Okay? Okay. So, this should just help you. We'll finish this off, and then that'll be the end of this, and then we'll jump into today's stuff, okay, with this, which is the orders of operation. Okay, so I don't know how many of you, this isn't an overly difficult concept. I don't know if any of you went to home and got this done or whatever, right? It says evaluate. Do we know what evaluate means? The word evaluate just means like, here are some like conditions, tell me what the answer is under those conditions. That's what it means, basically. Evaluate. Okay, so it gave you two conditions. I've highlighted those in yellow. It told you that x was -2 and y was -5. Okay, so this is another funny one that, like, such a funny, this is what's perplexing, not perplexing, this is what I think keeps teachers coming back sometimes to like do more and more, is like see funny things, and we like as at a heart of our profession try to like figure out why you as students do what you do sometimes, right? And this is one of these things that like some kids just they can't wrap their head around this for whatever reason. But it told you what x and y are, right? So for each of these questions, when it says evaluate, it told you what the parameters were. So you come down here and you say, okay, well, here's my like kind of question, if you will, right? And it wants you to evaluate when x is -2 and y is -5. And so all you have to do is come down here and you say 2, what is x equal to? First, yes, Colson, yeah? Okay, first off, how are these, before I get that too far, what's going on here? What's this actually mean? Sorry, that's maybe a point of confusion. We can stop and talk about that. What's that mean? You see three things written beside each other. There's no addition, there's no subtraction, there's no brackets, there's no dots. What's it implied to be? Good, lots of hands, yes? Multiplication. Okay, so if you don't see anything, it's implied to be multiplication. Okay, so what's that mean then? Okay, well, we're going to go 2 times x. Well, what did we just say x was? -2. And what is y? Well, we said y was -5. So you're just going to multiply those. Okay, 2 times 2. Doesn't matter what order you do it in. You could do it whatever order you want that suits your mind. You're all going to do it in whatever order you see fit. It's a personal thing, right? Some of you like 2 times 5 and then multiply by 2. Some of you are going to like 2 times 2 and then multiply by 5. Doesn't matter. We're all going to land at the same answer, right? So if I were to do another line here, I'd do the 2 times -2. That'd be -4. And then I'm going to take that -4 and I'm going to multiply it by the -5 sitting there. Okay, these are like, it's tough to tell how fast to move, especially with a new bunch of kids such as yourselves, right, with me, and I don't know where you're at. But these are issues, like I see these issues come up in grade 10. It gets kids wrong answers, and it's just a source of stress that it's an unneeded source of stress. And there's some things like I just want to take our time through some of this, that like we don't make any silly mistakes going through the course. Okay, there are going to be times where there's hard stuff, and that's okay to make mistakes on that. But stuff like this, we got to be able to figure this out. Okay, we'll just tells you what to do, and just plug it in. That's all. Just gonna, everywhere you see an X, you're gonna replace it with what it told you X was, and so on and so on. Okay. So with this one, I'm gonna take 50, and I'm gonna divide it by. Well, I'm gonna rewrite the question, I suppose. Divide by x, y, and then you just plug it in. So it's 50 divided by what is x? Well, it's -2 times -5. You can do the math in the denominator. 10. And what is 50 divided by 10? Well, maybe we want to see a little trick. I don't know if it's how much of a trick it is. You can scratch out the zeros. If you're dealing with really big numbers and you got some zeros, and you got zeros in the numerator and zeros in the denominator, you can scratch some out. Okay, so there you go. What's the answer? What's 5 divided by 1? That's an easy one. Everybody can see that. What's anything divided by 1? It's just whatever that thing is. Okay. One more. -2 times -5 plus -2, take away 4 times -2 times -5. We happy? Now again, this would be an instance, like, I know you're all sitting there maybe thinking, oh, this is, well, like, there's an issue here, and it can go wrong if you're not being careful. Okay? And I will bring that to your attention in 1 second. Okay? 2 negatives make a positive. So 2 times 5, that one's straight up 10. Okay? And then what happens when we add a negative number? What dominates? What's more powerful, a negative number or a positive number in terms of math? Not really real, but just what takes control when you have 2 of them beside each other? Yes, the negative. Okay, so what happens here is, like, you say, okay, this is going to be -2. Okay, now you need to be careful with this last part. Okay. Sometimes what I advise is just to write the minus sign and then do the math that's sitting here. And the more negatives that you start mixing in there, the easier it is to, like, flip-flop around and make a mistake on one, and then you get a plus where there should be a minus, or vice versa. Okay, so my advice is, as we go, like, just leave the minus that's sitting there, the black minus, and then do the math that's inside that black box. Okay, and keep it straight. Okay, quite often what I think ends up happening, and not that kids can't do this, they try to do this all in one line, which is probably fine for 90% of the time. But on instances like this, it's very easy just to make one sign error and then your answer's wrong. Okay, so when we say, like, just show your work, it's okay to have many steps. I know for me, like, what takes most people maybe like 3 steps, maybe it takes me 5. Right, because I just don't want to make any sign errors. Okay, so let's do the math inside the box, and then we'll just subtract that answer off. 4 times 2 times 5. Basically, right? 2 negatives make a, oh yeah, it's positive. So I see the 2 negatives inside the box, and 4 times 2 will make, or you can do whatever you want. 4 times 5 is 20 times 2 is 40. Right? Is everybody okay with that? Doesn't matter what order you do that in. All right, we're going to take off 40. That'll be the product inside the box there. Then you can use some of your skills from yesterday. 10 take away 40, take away 2, or 2 take away 40 plus 10, or -2, sorry. You can do whatever order you want, right? But we can do what's here, it's fine. I'm kind of seeing 10 take away 40. We know that to be -30, and then take away another 2. Okay, and that would be it. Did I do that too quickly for anybody? Are we okay?